they're less than one revolution on a circle. So part 2 will be locating angles that are greater than one revolution on a circle. Now we are going to look at 2 systems of measuring rotation. We're going to look at degrees and then also radians. And with radians we'll look at those that are with pi and without pi. Okay. Now I want to go over some assumptions we're going to be making. So I'll call these notes. So the first note, we always begin rotation from 0 degrees or 0 radians. And then 1 full revolution around the circle is equivalent to 360 degrees or 2 pi radians, or if you substitute 3.14 as an approximation for pi, 6.28 radians. Okay. And the last note we're going to make is that we assume we already know certain points of reference, certain angles that are very important along the circle. So let me just kind of cover those a little bit. If you know that 1 revolution around the circle is 360 degrees, then 1/4 of 360 is going to be 90 degrees. So moving in the positive direction around the circle and starting at 0, this is going to be 90 then. Halfway around the circle, or half of a revolution, is going to be half of 360, or 180. And then 3/4 of the way around the circle is going to be 270 degrees. So that's going to be here. And finally, full circle again, where you'll end up exactly at the same place where you started at 0 degrees, but your rotation's 360. And continuing that, we'll do that for radians. So if you look at, again, the quarters, 1/4 of 1 revolution is going to be 1/4 of 2 pi, which will be pi over 2. So this is pi over 2. And then half of a revolution is half of 2 pi. So pi radians here. And then 3/4 of a revolution is going to be 3/4 of 2 pi, or 3 pi over 2. So of course, starting at 0 here, you can move all around the circle, and then when you come back full circle, you're at 2 pi. And then lastly, same idea, just putting in radians. If you just substitute 3.14 as an approximation for pi over 2, you'll get 1.57. Of course, 0 is still 0, and that's radians. This will be pi radians, or 3.14 radians. And this will be 4.72 radians. And finally, 6.28 radians. So combining all of this, what you should keep in mind always when you're working on local angles on the circle are these points of reference then. 0 degrees, this is 90, pi over 2, 1.57 radians. This is going to be 180 degrees, or pi, or 3.14 radians. Over here, 3 pi over 2 radians, 270 degrees, 4.72 radians. And finally over here, 2 pi, 360 degrees, 6.28 radians. So you need to keep these in mind as we go through the examples, because that's what's going to help you keep your bearings as you're going around. So, our first example we will look at is 197 degrees. Where will that be? So, in my head I'm thinking I start at 0, I'm rotating in the positive direction, I pass 90, I pass 180, and I'm between 180 and 270, but where exactly in here in quadrant 3 am I? So, quick little calculation, how much more is 197 from 180? Then it's 17 degrees past 180. So essentially it'll be, who knows, we'll just kind of guesstimate here, something like that. So our rotation is something that looks like that. Example 2. Negative 307 degrees. So again, thinking about our references, we have 0 degrees. Now we're going in the negative direction, so we're going this way. So this is going to be negative 90 degrees, negative 180, negative 270. So we're past that. And now we're somewhere in quadrant 4 heading towards negative 360, which would be same position as 0 degrees, but different rotation. So how much more is 307 than 270? Well, let's do a subtraction and find the difference. It's 37 degrees more. So we're going about 37 degrees past 270. It's in the negative direction. That's what your rotation will look like. Example 3. 2.3 radians. Okay, let's get our bearings. We're going in the positive direction, starting at 0, passing 1.57, and not quite reaching 3.14 radians. So we're somewhere between 1.57 and 3.14. And again, how much more? Let's take 2.3 and subtract 1.57 from it. And we get about 0.73 radians. So we're about 0.73 radians past 1.57. And one thing to notice here is that in the rotation from 0 to 1.57 is 1.57, and then going from 1.57 to 3.14 is an additional 1.57 radians from 1.57. So each quadrant, you're basically rotating through 1.57 radians. So 0.73 is not quite half, because if I rounded 1.57, I'd say 1.6, so that's like 16, and 0.7 would be like 7. So if you had 8/16, you'd have exactly half, but you're really close. So you could say something like that. Just almost halfway into quadrant 2. So that's going to be 2.3 radians. Example 4. Negative 0.9 radians. Okay. So you're 0 radians, and you're going in the negative direction. This would be negative 1.57 radians. So you're only going 0.9 radians. So you're a little past halfway. So maybe something like that. And you're negative. Okay. Example 5. 2 pi over 3. Well, this really is 2/3 of pi. So thinking that, if you look at a circle, and here's 0, here's pi. If you went all the way, that would be pi. But we're only going 2/3 of this distance, so we want to divide this distance into thirds. So we'd say, here's about 1/3, here's about 2/3, here's about 3/3. So this would be pi over 3, this would be 2 pi over 3, and this would be 3 pi over 3, which is the same thing as pi. So essentially we're out here, and this is our rotation. Example 6, negative 3 pi over 7. And again, this is really negative 3/7 of pi. Okay. So here's 0, and we're going in the negative direction, so here's negative pi. So again, all of this here is a whole negative pi, but we don't want a whole negative pi. We want to divide that into sevenths and then take 3 of them. So let's say 1, 2, 3, 4, 5, 6, 7. So this would be negative pi over 7, negative 2 pi over 7, negative 3 pi over 7, negative 4 pi over 7, negative 5 pi over 7, negative 6 pi over 7, and finally negative 7 pi over 7, which again is negative pi. So now that we've got our divisions, we're going to go out to the negative 3 pi over 7. This is our rotation. And our last example, example 7. 9 pi over 5. Now here we have an improper fraction, so I want to figure out how many wholes are there. So I want to divide 5 into 9, and I would get 4 parts left over. So 9 pi over 5 is essentially 1 4/5 pi, which is really 1 pi plus another 4/5 pi. So let's take a look at that on the circle. So here's 0, we're going around positive, here's pi, so this here would be pi. And then, not only do we go that 1 pi, so I'll put that there, we're still going to go 4/5 of the next pi, where this other part would be pi, but we want to divide that in fifths and take 4 of them. So 1, 2, 3, 4, 5. So here would be pi over 5, an additional pi over 5, and 2 pi over 5, 3 pi over 5, 4 pi over 5, and finally 5 pi over 5. So we will end up here at 4 pi over 5. Together we go 1 pi plus another 4/5 pi. And that's for our rotation. Well, thank you very much.